All right, so rational algebraic expressions. So a rational expression has some algebra in it, but because it's an expression, means it's not going to have a what? An equal sign. So something you usually see it written in like fractional form. So like 4x y to the second over 8y. And then really all you need to do is simplify or reduce. So on 4x y squared over 8y, check your coefficients first, right? You've got a factor of 4 and 8, so 4 goes into 4 once, 4 goes into 8 twice. Got an x up here, not down here, so that's good. And then a y to the first and a y to the second, so this one completely cancels and this becomes y, right? So if you just want to simplify it, you're going to look for, or end up with xy over 2. Right? So when you get into what we call rational algebraic expressions, you're going to need to factor first. That's why we spent quite a bit of time factoring before we get into simplifying those rational expressions. All right, so example number 1, we're going to get something like x squared minus 2x over x squared minus 4. So because there's a minus sign, or it could be a plus sign, because there's a plus or a minus between the terms, that means you're going to need to factor before you just start canceling. You can't just go, oh, there's an x squared and there's an x squared, so cancel them. Can't do that. You're going to have to go through all those steps. Look for your GCF. See if it's easily factorable. See if it follows one of the patterns. You might even get some that are harder where you need to do the slip and slide on it, okay? But they start pretty easy. So the numerator has a GCF, right? Because both those terms have an x in them, factor out an x. That's going to leave you with x minus 2. Okay. And then the denominator doesn't have a GCF, but this is a special pattern, right? What does that factor to? X plus 2 and x minus 2. Okay, so from here you should be able to see, oh, I see what's going to cancel. There's a factor of x minus 2 and a factor of x minus 2. So we are left with x in the numerator and x plus 2 in the denominator. Okay? That's as far as you can simplify it. Because there's a plus sign. If there wasn't a plus sign and it said 2x, cancel the x's. But because there's a plus, or it could be a minus there, you can't factor anymore. Okay? All right. So some of the questions will say, for you to say what the domain is. Okay? So if it gives you that question, you need to look at the denominator. And so you want to take that denominator of x plus 2, set it equal to 0, and then solve for x, so you'd get x equals negative 2, which means you'd say something like this. For the domain, you'd say all real numbers except the one we just got. Except we just got negative 2. Right? So, why? Because if you plug a negative 2 in there, what's negative 2 plus 2? 0. So you can't have a 0 in the denominator. So, but you can plug any other number in there. Like if you plugged a 3 in there, you'd have 5 in the denominator, and that's good, right? Or if you plugged in even a negative number, negative 7 plus 2 would be negative 5. It's okay to have negative 5 in the denominator. You just can't have 0 there. So wherever that denominator is equal to 0, you say all real numbers except that. Sometimes there could be 2 of them or possibly 3, but usually just 1. Okay, the other question it'll ask you is, what are the zeros? What are the zeros of this expression? So for the zeros, you're going to look at the numerator. And we just have this x. So you're going to set the x equal to 0. But we also, before we factored, we had that x minus 2. So the zeros of this expression are at 0, and the other one, if we add 2 to both sides, we get 2. So those are the 2 zeros of the expression. That just has to do with when you start graphing these, that's going to be where they cross the axis. Okay? All right, let's look at one more example, example number 2. Move it up and shrink it. There we go. All right, we've got the quantity 3x minus 5x squared minus 2x to the third times the quantity 6x squared minus 5x plus 1 to the negative first, okay? So this is just fancy writing. What does this negative, to this exponent of negative 1 do to this? Moves it to the denominator, right? So it's basically moving this part of the expression down to the denominator. And this part's already in what we call standard form. So I'm just going to write 6x squared minus 5x plus 1. This factor part right here is not in standard form, so I'm actually going to rearrange these so that they are. So I'm going to start with the largest exponent of 3, so it's going to be negative 2x to the third. This one should come second because it has a power of 2. And then plus 3x. This one has quite a bit more factoring than example number 1 did. Okay, so let's start with seeing if we can get a GCF out of there. So in the numerator, is there a GCF? Yes, they all have a what? An x, and the leading coefficient has a negative. So I'm going to factor out a negative x, which is going to make my leading term positive 2x squared, then a 5x, and then a minus 3. Is there a GCF for the denominator? I don't see one, right? So I'm just going to write 6x squared minus 5x plus 1. All right, so now let's look within these parentheses right here. Does it follow a pattern? Is it like perfect squares? No. Is it easily factorable? No, because it has that leading coefficient of 2. So let's do slip and slide on that one. So I'm going to take that 2, multiply it by the negative 3, so I'm going to have x squared plus 5x minus 6. We're just going to have to remember to multiply or divide by 2 in just a second. Okay, so when we go to factor, obviously we're going to have x and x. What 2 numbers are going to multiply to get negative 6, but add or subtract to get positive 5? Positive plus 6 and minus 1, right? Okay. So let's divide each of those by, we just multiplied by 2, so divide by 2, divide by 2. This one simplifies all the way to 3, so that's going to turn out nice. But this one can't reduce, so we have to slide that 2 over. So the factors here are x plus 3 and 2x minus 1. So that's what our numerator is going to factor to. Now let's do slip and slide on the denominator. Okay, so this one we have to multiply by 6. So that's going to become x squared minus 5x plus 6. Almost the same trinomial we had up here, but notice the signs are different. So when we go to factor, what two numbers will multiply to get positive 6, but add or subtract to get negative 5? Negative 2 and negative 3, so x minus 2, x minus 3. And we multiplied by 6, so we have to divide by 6, divide by 6. This one reduces to 1/3. This one reduces to 1/2. So this one, when we slide over the 3, is 3x minus 1. This one, when we slide over the 2, is 2x minus 1. Okay, so now that we factor, there should be some stuff for us to reduce, right? So the numerator was x plus 3 and 2x minus 1. And the denominator is 3x minus 1 and 2x minus 1. Right? So what's going to cancel the 2x minus 1? It's the same in the numerator and the denominator. So we are left with the x plus 3 over the 3x minus 1. Oh, and we pulled out a negative x up here too, right? Let me move that down. Squeeze in that negative x right there. Okay? If you want to distribute it back into the answer, you can, but I actually prefer it to be written like this. So, if they ask for the domain, that's where you look at the denominator. So where is 3x minus 1 equal to 0? Should be a fraction, right? Add 1 to both sides. Divide both sides by 3. That got 1/3. So x equals 1/3. That means all real numbers except 1/3. And then the zeros had to do with the numerator. So negative x equals 0 at 0, because even if you divide it by negative 1, you still have 0, right? And the x plus 3, set that equal to 1. Sorry, set the x plus 3 equal to 0, so subtract 3, so x equals negative 3. Is there another one? Yeah, the 2x minus 1. One more. 2x minus 1 equals 0. I'm going to get 1/2 just because I'm running out of room. So there were 3 of them. There's this one, and this one. Okay? So the hardest part on this is the factoring part. But most of you did really well on that factoring test. So let's see it in action.